So what we're going to do now is we're going to add a little bit more security on the policy you just created. It's good. It's actually doing a good job. But it could be better. It could do more. And we're going to add file type enforcement, and we'll talk briefly about our attack signatures as well. Now, before I actually get into the file type enforcement, I want to give a little bit of information about what I think is a big benefit of using ASM to begin with versus some of our other security products that we have out there. Most security products that we have out there utilize a specific kind of security model. Now, before I get into that, what are some of the other network and application and any other kind of security products we have out there in our enterprise?
APM?
Let's say not F5 product names, but just product types.
Next-gen firewall.
I'm sorry?
Next-gen firewall.
Okay, next-gen firewall.
IDS,
IDS, DLP, all good answers. What about on the client side for your clients?
Antivirus.
You usually use antivirus software technologies as well. So these are all different kinds of security products, and most of them use the negative security. I can recognize something bad. I know when something bad is happening, like antivirus software. That's what antivirus software is based off of, is negative security. We can recognize it because of what? How can I recognize something that's triggering my antivirus? Signatures, right. Before we get to that, we also have the positive security model, where I know things that are good. I can recognize good traffic. Those are two different security models that are typically used by most security products. And as we just said, just asked you this, how do we typically recognize bad traffic, malicious traffic? It is through attack signatures. That's what most of our security products are using. But we can also have blacklisted items, for example, in AFM or any network firewall, any network firewall. I can blacklist certain source locations. So these areas I'm blacklisting. I know that they're bad if they come from this region. On the positive security side, how do I recognize something as a valid request? There are a few ways of doing it. One of the most common is a whitelist. I can create whitelists of things. For example, what we're going to do in this lesson is file types. I'm going to create a whitelist of the allowed file types for this web application, PHP, HTML, and so forth. We can also create whitelists for a few other kinds of things, such as the list of all the valid URLs, the list of all the valid parameters. I just talked about those a little bit earlier today. Even cookies. I can have all the list of cookies that are available. And what happens is, with ASM, we can use both of these. I can have all these aspects about a web application that I've identified as valid. I can look at a request and say, I know that's valid. But I can also utilize the concepts of the negative security, where I can recognize something that's malicious. And ASM lets us put all of that together. Not a lot of security products do that. We take the best of both. For example, when I have a request that comes in, I'm going to make sure it matches my positive security first. If it matches the positive security aspect of my web application, my security policy, then I know it's good. That's a good request. But wait a minute, we still have to make sure that it doesn't match something in my negative security. Because if it does, then I can say, no, that's malicious, that's bad. So we don't have to take advantage of both. We don't have to use positive security, we don't have to use negative security, but we can. And I think that's what really makes ASM unique in being a product. We're going to be focusing mostly in this lesson on file types. But later on after lunch, we're going to add URLs and parameters to our positive security as well. So when you guys finished your last exercise, once you were done, before you deleted your policy, I had you delete your policy at the end, but before you did that, there is a page in our configuration utility called the allowed file types page. These are all the file types that are allowed for this web application at this time. And this is exactly what your page would have looked like if you had gone and taken a look at this page. Presently, this is the list of allowed file types for your security policy. That's the default. What does that mean? What is the little icon there identifying?
Old file type.
Yeah, so it's the wildcard, the asterisk. And it's saying right now, okay, the only allowed file types are everything. All file types are allowed. What we want to do is we want to get this policy down to where we only have the list of file types needed on the back-end server. So our ASP, ASPX, HTML, HTML. Every web application has a finite list of file types that are needed. There are some real benefits to using this. I think every security policy you create, you'll want to add this file type enforcement. And here's why. Number one, it's very easy to set this up. I've only got a somewhat short list. It's usually 10 to 20 file types tops for most web applications. Number two, as this application is evolving in the company, they're usually adding things like new URLs, they're adding new images, maybe they're even adding new forms and interaction. But they're rarely adding new file types. It's possible, but rarely are you going to see new file types being added to the list. So once I've created this list, I can pretty much leave it alone and I don't have to worry about ongoing maintenance. The same can't be said for when creating a URL list. URL list is constantly changing. They're adding new URLs and so forth. We'll talk about that later. But in addition, this adds a really good amount of security. It blocks against several kinds of attack types, especially for the amount of small work used. For example, if any of you remember the Code Red attack from years ago, that is an attack that exploited the back-end configuration files on a web server. Every web server has configuration files. These are files that we need in the web server directories, but they're not files users are supposed to be accessing. And that's how developers exploit things. So by creating this list of file types, organizations would have been totally protected against the Code Red attack. Now, at some point, I will feel very confident that this is a complete list. This list is done, and I'll want to address this wildcard. Because as long as I leave the wildcard in there, I'm saying only allow these file types and anything else. So at some point, I'm going to want to make sure to remove that wildcard to be completely done. So there's our list of file types. That is what I call our file type whitelist. You don't really see the term whitelist inside the UI. It's just what I call our whitelist. Now the question is, how do I get that list? Where does that list come from? And to answer that, there's a couple of different possible scenarios. One is I might come over here to my team from Singapore. I'm like, okay guys, we're ready to build your security policy, so can you please bring in your developers of your application, the people who know all about your application. And in Singapore, they got everything together. They got everything you always need. They're on top of it. So they bring those people into the meeting with us, and I say, hey, I need to know all of your file types. They give me a list. And then I can just go into the UI and use that create button. And I can create each file type one at a time. That'll take me 5 minutes, tops, to create that list, and I'm done. Pretty easy. That's great. But then there's this other team here from the US. And I say, hey, I'm here to build your security policy. Can you please bring in your application security team And in the US, we're not quite as together as they are in Singapore. They're like, I don't know who those people are. I think we've had this application built like 4 or 5 years ago. I don't think there's really anybody here that knows much about this application. Sorry. So I can't help you. So now, we need some help to build that list. We need someone, something, to help us build that list of file types. Who do you suppose is going to help us?
So we can enforce our policy in staging mode and get a report of the user.
Oh, you're going way above and beyond. Just who's going to help us?
The BIG-IP.
And ASM. The BIG-IP and ASM. And then you were explaining how, which we're going to look at here. But yes, so ASM is going to do this work for us. Since they can't help us, we're going to have ASM do the hard part. And that's what these next few slides are about. If you've got the company that knows what they're doing, you don't even have to go through some of this. This is because we need ASM to do it for us. So there's a couple of pages in the UI that you're going to really want to get to know when you're doing a lot of work with ASM. And this is one of them, the learning and blocking settings page. This page was actually developed in like version 13, and it was a great addition to the UI, because before that, all the things that were on this page, they were available, but they were in different spots. You had to go to all these different places to do everything. So everything's now in this one page. So we're going to take a look a little bit at this page first before we talk about what we need to do to get ASM to learn all that stuff for us. One of the things we can do on that page is we can change some of the top level settings of the policy. For example, are we in transparent mode or blocking mode? This is where we can switch. We're going to talk about a couple of these other options a little bit later after lunch as well. And then down below that, we have all of these different categories of violations. These are all categories of violations. If I open up any one of these, such as my general settings, I'm going to see some different violation types. Each one of these is a violation. And it's important to note that not all violations are malicious. They're just things that trigger something. Now, when you go to look at your learning and blocking settings page right after you build your policy, you'll see some items in here already selected in these different various categories, and that's because of the template type you chose. So rapid deployment template type or fundamental template type, they all have some options enabled by default. Now, before I get into these checkboxes, I want to point out that you're not going to know what all these violations are. I don't know what all these violations are. I haven't spent that. I've worked with ASM for years, but I've never memorized all these violations, and you don't have to. For any one of these, you can click on that little triangle, and it'll give you more details about that violation, the nature of it, and what I really like are some of the attack types that you'll see that exploit that potential violation. That's kind of cool. So let's talk about these three checkboxes or four. That's the important part of the learning and blocking settings page. We have the learn column, the alarm column, and the block column. So for any one of these violation types, I can ask ASM to tell me every time a request comes in that triggers that violation. Doesn't mean it's malicious. It just means it triggers that violation. So I can ask ASM to tell me every time it sees a request that does that. And that's what the learn checkbox is going to do. On the very next slide, we're going to look at the learning slide, the traffic learning page. Excuse me, the slide. We're going to look at the traffic learning page. That's going to be where we're going to see everything ASM has learned. It's only going to learn about violations that we ask for it to learn. Then, once I'm building my policy and I'm tuning my policy, each one of these violations is getting tweaked a little bit. You'll see that more in lessons 3 and 4. Each one of these violations is getting tweaked to a point of completion. And requests might come through by users that violate the current attributes for that violation type. The alarm checkbox says that when requests come through that violate the current attributes of any one of those violations, and we're still in transparent mode. Remember, nothing gets blocked in blocking mode. So when a request comes through and it violates that violation, then we're going to see an illegal log entry in the event log. So we will see that log entry, and that gives us some visibility into what is going to get blocked when we eventually move to blocking mode. Anything that's triggering an illegal log entry is going to trigger a blocked request entry once we move to blocking mode. So that's what the alarm column does. The block checkbox, once we move to blocking mode, any requests that come in that trigger and violate that particular violation type will get blocked, and they'll generate a blocking log entry for us in the event log. So that's what those three columns are for. You'll notice we don't have all of them selected because we're not worried about every aspect of a potential security policy. We rarely would want all of them selected. So the whole point of coming here right now is I want to do two things. I want ASM to tell me about all the file types that we have, and I want to prepare myself that once I have my completed file type list, I want to do something with that. I want to use it to potentially block malicious requests. So we're going to be using the category of file types. That's got its own category. And the first entry in there is the ability to learn new entities, to learn new file types, to learn new file types. So the default right now says, no, just use the wildcard. In other words, allow all of these. Allow all file types. We're going to be changing that to one of these three options there. Compact, selective, and always. I don't say you should always use always, but the thing with always is that's going to give you the most comprehensive list of that type. So in other words, this is going to tell me every single file type. Compact and selective tend to group them together so you get less total control. I also like to say it. Less total control. I want to know every single file type or every single URL or every single parameter. I use always. So that's the first thing. This is going to allow ASM to start telling us everything that it's learning about file types. Then secondly, I need to do something with that. And we have 5 violations about file types. 4 of them are linked violations. Link violation, link violation, link violation, link violation. We'll talk about those after lunch. All that matters to me right now is the illegal file type violation. Once I have a configured list of file types, when somebody sends a request that's not in the list, that's going to trigger either an illegal or a blocked concept. So I need to do something with this violation. This is going to say, show me everything you learn about file types on the traffic learning page. Once I have a file type list and I'm still in transparent mode, give me an illegal log entry anytime somebody sends a request that's not in the list. And then once I'm in the blocking mode and I got my file type whitelist, if somebody submits a request that's not in my list, I want it blocked and I want a blocking event log. So I'm going to set that up as well. That's all I need to do. Even though I covered a lot more, it took me a lot longer to explain this than it did to actually come in and do it. I just come to this page, I select this, I select those, I click on Save on the page. And just like APM and AFM, we do need to make sure to apply the policy every time we make any kind of changes to the policy. And then I can sit back and wait for something to happen. So at this point, I need to now generate some learning suggestions. Learning suggestions. How do you suppose we're going to go about generating learning suggestions?
Ask the user to use the application.
Somebody has to use the application. Somebody has to use the application in the manner that it's intended. In other words, request the home page, which also requests the logo. And now what's going to happen is every time ASM gets positive 200 response codes back, it's then going to add the appropriate file types to the suggestion list. It only does that for requests that get valid responses. So if I'm typing in a bunch of bogus URLs with file types that don't even exist, ASM does not add those to the whitelist. And this continues as users continue to use the web application. As long as they get the PDF response, we will add that. But it's important to note, these are only suggestions. And as we continue to see the same file types requested more than once, this user also requested an ASP file type and a GIF file type. ASM, the policy builder keeps track of how many times each file type is requested. That's for our benefit. But I can see, over the last week, the ASP file type was requested 25,000 times. That gives us some information that, that probably is a valid file type. But remember, these are suggestions only. At this point, a malicious user could try to do what's called a forceful browsing attack to view some of our confidential configuration files. As long as that file exists, it's actually on the web server, we're going to send it back. The user is going to see it. We get a valid response code. That file type gets added to the suggestion list. Just because it's on the suggestion list does not mean that I'm going to eventually want to add it to my whitelist. I don't want people accessing these configuration files. Now we can do this in production if we choose to. If that's our only option, we can also do it in a development environment. As long as we're pushing traffic through ASM, ASM is going to give us results. But it's important to remember that if we're in production, it's very possible we're in transparent mode, which means we're not doing any blocking, which is why that user was able to pull up that CONF file. So how long does this take place? How long does this last? Well, it depends upon the scope of the application. If this is a really big travel website, a lot of functionality, we might let this run for 2 or 3 weeks. But at any time, we can go in and we can start viewing everything ASM is learning about. Everything it's learning about using that other page I was telling you about, our traffic learning page. This is another page you'll do a lot of work in when you're an ASM user, an ASM expert. You'll do a lot on the traffic learning page. These are all of the items that ASM has learned about. Everything it's learned from user requests. As you go down, you'll see we have lots of items in here, a lot of the legal file types, but other stuff in here as well. All these interesting things ASM's learning about. As a reminder, anything that we had, the learn checkbox, any of these violations, this is now ASM telling us, hey, this happened. That doesn't mean it's malicious. In fact, quite often these aren't malicious. For example, let me go back for a second. For example, HTML, illegal file type. That's not malicious. So why is it put it in here? Well, let's see. What's currently on my whitelist? What's currently on my whitelist on my file type whitelist is that. So that means any file type that is not that is illegal. But that doesn't mean they're malicious. But they are illegal because they're not on my list. So that's an example that not every triggering of a violation type is an illegal thing. Many of these items in this list we actually want to add as part of that positive security model. We can say, oh, you know what? That's actually a valid thing. And I want to allow users to do that. That's part of a positive security. Such as adding something to a whitelist, adding the HTML file type to the whitelist. Some suggestions are malicious, and they should not be added. We'll talk about that in just a moment. Anything that's truly malicious should not be added, because we're essentially then adding something malicious to our positive security model. So first I'll talk about how to add some of these new learned file types to the whitelist. So here's a file type, no_exe. No exe. What is that? What is that?
No extension.
What does that mean, no extension?
A web page without a file type. For example, f5.com/contact.
How about just f5.com? f5.com. This is what the users submit. Are users likely to submit URLs like this to our web server?
Yep.
Very likely. This is probably what we're going to get more often than not. Once they start clicking on links, the links will go directly to a page. But to get to my web page initially, users do this. So what is the file type in question there? What is ASM going to see as the file type? So there is none. Now, once it sends it to the web server, sure, the web server knows it should give out a default page. But ASM doesn't know what that web page is, and it doesn't care. All it cares about is, what's the file type? There is none. So the question is, do you think I want to add the no_ext file type as an allowed file type on my whitelist? The answer would be yes, only if you want people to be able to do this. If you did not add no_ext as a valid file type, every user to get your website would have to know that they need to go to f5.com/default.jsp, enter, or their request would get blocked. This request would get blocked if we didn't use no_ext. So yeah, we typically want to add the no_ext file type. So I want to show first some of the information ASM keeps track of for us. For all of these learned entries here. We'll use the illegal file type for PHP. The first thing you'll notice is it's got this number over here. This is called the learning score, and we're going to talk about this more after lunch. But the short explanation is the higher the score, the more likely this is valid. The more likely this entry should probably be added to our positive security. But it's not a guarantee. It's just likely. In addition, when I select any one of these entries, over here on this side of the page, we have a lot of details, a lot of data. For example, this is going to show me how many total times this was requested by different unique users out there in different cities and countries and times of the day and web browsers and so forth. The higher this number, the more likely that's a valid entry. Down here, you can see, in this case, you can see all of the URLs that this particular violation occurred on. And so in this case, these are all the URLs that use the PHP file type. And I can look at those and say, you know what? Those are all valid URLs. Why do we have all this information over here? It's to help us make decisions on whether or not that entry over there is good or malicious. So this is helping me. I'm looking at that going, yeah, I think those are all valid URLs. And if I'm not even positive on that, I can select any one of these. And then over here, we get information about that individual request, where it came from, this information. Boy, it's really tight down there. So we have this little icon here that'll let you open up that, and there's so much data available. You can see everything about the request. If there's any possible attack types attached, you'll see that here. I don't think we don't have an attack type, so that's good. That's a good sign. Down below that, you'll see the full HTTP request. The request line, the headers. If there was a body, you'd see the body, but there's no body because it's a GET request. And potentially, if it's enabled, down further, you can actually see the HTTP response that was sent back to the user. So again, why do we have all this? We have this so that we can, application developers who are building the security policies, have some insight into whether or not these entries are actually valid or whether they're actually malicious in nature. That's what all that information is for. And when I've identified something as...
Are we able to specify whether we want a special file type just under a certain directory as well? For example,
that would have to be done through the URL. You'd have to go to the URL level to do that. When you just have file types like PHP, it doesn't care in what manner the PHP is accessed. Not just with file types. But you can do what you're asking if you're now using URL level protection as well. So I've now decided I want to add the PHP file type to my positive security model, meaning I want to add it to this whitelist. So again, I feel like we make this very easy in ASM. I can select the entry, and over here on the right, we have this button here, this accept button. This button is incredibly important to understand what this does. Let me first explain what it does, and then I'll explain how people can make a mistake. What this does, this will always add something to our positive security. In some manner, it's helping us identify valid requests, things that are valid. In this case, what it's going to do is it's going to add a file type, and it tells me exactly what file type it's going to add. This action is always going to tell you what ASM is going to do if you click on that button. And I'll give you an example of how this can be done wrong. When somebody does not know what they're doing, one of the things you're going to see in this list is every time a signature violation happens. So for example, somebody has just sent a SQL injection attempt. I'm going to see an entry in here for an attack signature that was triggered. Now some people think, oh, I want to enforce that signature. I want to make sure that signature blocks things. So I better select that signature entry and then click on this button. But unfortunately, that's not what we're doing. When I take a malicious entry, like a signature violation, and I click on this button, I am actually now saying, I want that signature violation to be part of my positive security, meaning they're allowed to do that signature. That signature is allowed through my web application. So the moral of this button is this will always add things to our positive security. They're now allowed in this website. PHP is now going to be allowed. And when you click on it, there's two options. Add it and enable staging. We're going to talk more about staging after lunch, so don't worry about that right now. So I'm just going to select that second option. And then you're going to notice the suggestion's gone. It's no longer here. And you will never, ever see the PHP as an illegal file type entry ever again. Why not? Because it's now been added to the whitelist, and it's no longer an illegal file type. So I'm going to want to go through that process for all of my valid file types. And that could take a while. I got to select one and add it, select another one and add it. Especially if this is a really long list, thousands of entries in here. So So we have some ways in ASM to do this faster. One is we can just see what I need to see inside of this list at this time. There's a couple of ways we can do that. This is filtering. We're going to do some filtering here. The first is I can just select another illegal file type entry. And then over here, I can choose to just see all of the entries that have the exact same violation type. As soon as I do that, I now just have all of my illegal file types in this list. And again, and we can see that now, we have a filter in place. Again, the higher the learning score, the more likely these are valid, such as no EXT, PNG, CSS. The lower the learning score, if they're 10 or 5%, that means they've only been triggered by a couple of users around the world. Most hackers are doing things from their own workstation, and ASM, we'll talk about this after lunch, by the way, ASM doesn't just take all the requests from this one malicious user and say, oh, 10%, 50%, 20%, 25%, and keep increasing the learning score. It's going to take one entry from this malicious user and then ignore the rest from them for a period of time, usually around 7 days. So in order for malicious entries, like malicious file types, to have a high learning score, we got to be getting requests from lots of users around the world requesting that. So more often than not, file types with a low learning score haven't been requested by very many users. So I can further filter this list using this button. And I can do a few different things. But what we're going to do is we're going to filter it based on the learning score. So now I'm only viewing file types with a learning score of 30% or higher. Now I have a smaller list, and I just quickly scan through all those. I've got my developers with me because it's these guys, or with us, we're going to look at all the URLs in question and say, you know what? These are all valid file types. So I can select them all at one time with that little checkbox. And then look, it shows you everything that's going to be done. Add this file type, add this file type, this one, this one, this one. We can do it all with one button click now. Quick way to add a lot of entries at one time. I then am going to change my search criteria, my filtering criteria. Now I'm just viewing all the file types with a low learning score, from 0 to 29%, and I'm quickly recognizing I don't want users accessing exe files, or txt files, or ini files, or md files. Those are all configuration files. I don't want to add those to the whitelist. So I can do one of two things. I could either choose to delete those suggestions or ignore those suggestions. And the difference of those two is pretty drastic. It's not drastic, but it's important to note. If I delete these 4 suggestions, all it takes is a few more requests from the malicious user, and they will reappear in the list. I may now see MD in this list again tomorrow. So it removes it from the list, but it can be re-added to the list. If I ignore those 4 suggestions, they will be removed from the list, and I will never, ever see those learning suggestions on this list again. So the way that I would advise this is if I'm looking at those, I'm like, oh, I think those are malicious, but I'm not sure. I'm pretty sure those are malicious. I'm not 100% positive. I'll delete them until at a time when I know, I'm confident. As soon as I'm confident that those are truly malicious, I never want them added to the positive security model, that's where I would ignore them. Get them out of the list for good.
So once you ignore them, would you be able to generate a list of ignore ones?
You sure can by using that same filter button, that same filter icon. You can go view all the ignored suggestions and so forth. Absolutely. So now I come back to my allowed file types page, and there are all the file types that I've added. These are all part of the whitelist. As a reminder, as long as this stays in here, all file types are considered, they're not malicious yet because we have the wildcard. So at some point I need to make sure to remove that. I will do it when I'm confident this is my final list. You can just select that checkbox. At the bottom, you've got the delete button. And at that point, now, this is the finite list of file types that ASM will allow. And what ASM does to a request that doesn't match that depends. Are we in transparent mode or are we in blocking mode? So if somebody accesses a .ini file and we're still in transparent mode, will the request be allowed or blocked? Sorry? It will be allowed. I already told you. We don't block anything in transparent mode. So what happens that's different now? What happens now that's different when somebody accesses .ini file type that didn't happen a couple minutes ago? We're going to get that log entry. This is where we're going to get the illegal log entry, and it's going to show us, hey, somebody accessed this illegal entry, INI. It was still allowed because we're in transparent mode, but as soon as you're going to move to blocking mode, that request will get blocked. And it will. As soon as we go to blocking mode with this policy, this request would get blocked. One last thing here. Note, all of these file types, they're in staging, says yes, we'll talk about that after lunch. So don't worry about that right now. And by the way, don't forget the declare policy. It doesn't take effect. So the last thing we'll talk about, and then we'll get into lunch and your exercise and so forth. Just talk briefly about some of the attack signature options we have. Again, attack signatures are the basis of our negative security. Remember that we have all these aspects of an HTTP request. Everything. We've got the request line. We can check for attack signature violations in the URL. We can check for attack signatures in the query string. We can check for attack signatures in the data portion of a post request. We can check for attack signatures in any of our request headers. In fact, we can check for attack signature violations in any aspect of the entire HTTP request. So there's a few different ways that we can maybe add some additional signatures if we want. One is we can use this page here. This page has been made, they've made some changes to the server technologies page, but it's still kind of vague what this page really does. Unless you know what it does, it may not be really clear what we're doing when I select the backend server technology. But that's what we're going to do on this page. Is we're going to say this web server, it uses Apache, it uses MySQL, it uses PHP files. That's what we're going to be identifying here. For example, we're using ASP pages, so we're going to select yes there. Now, if you're quick and you're savvy and you read this, this is where you might say, oh, I see, we're actually doing something. What ASM is going to do is it's now going to add additional attack signatures to the policy just for this technology type, just for the ASP server page type. And I can continue to do that. I can specify it's ASP, ASP.NET. What else do we have here? The Java servlets, SQL Server, Windows. So now what we're doing is we're just getting additional attack signatures, but they're just for our type of web application. We wouldn't want to do this if we were using Apache. We want to use the Apache option. And you don't even have to do this if you don't want. you don't want to take advantage of those additional signatures. You don't have to do that. That's just an additional way that we can add attack signatures. Another way that we can add attack signatures is on our same learning and blocking settings page we were looking at a few moments ago. We have the attack signatures category. This is showing us all the current attack signatures we have, including the ones we just added from the server technologies page. We can also use this button here, change, to add some additional signatures. These are all attack signature sets. So they contain a collection of attack signatures of that category. And they're all filter based. What that means is I have a filter that's looking specifically for signatures that have been tagged by my team in Tel Aviv. Every time we have new signature updates, all these signatures are tagged with certain criteria. So if we have new SQL injection signatures, they'll be tagged as a SQL injection signature. So this signature set is just a filter-based signature set that says add all attack signatures that are tagged as SQL signature. And that way, when we have new signatures updated from Tel Aviv, we'll automatically take advantage of any new SQL signature. SQL injection signatures. So I can select as many of these signature sets as I want to include more signatures. So why not just select them all?
Because it requires some resources on the BIG-IP to inspect all the traffic for all the signature.
So we're going to now be adding a lot more overhead on the policy, the more signatures. There's also another potential issue as well.
Maybe not relevant? Or
Definitely not relevant.
false positives.
And we might get a lot more false positives. Yeah, we want to be really careful. If we add too many signatures, we're going to trigger too many false positives. We really want to just add signature sets that are important to us. I'm really concerned about SQL injection and cross-site scripting. So the ones that you got in your last exercise was not a full comprehensive list. It was the most common SQL injection signatures and cross-site scripting signatures. I want them all. So I'm going to include those. And then at the bottom is where you'll see the other ones we added from the server technologies page. Now we've got all of our signature sets ready to go.
Is it the order of processing, top to bottom? Or?
There is no, I don't think there is any order that it's looked in. We can also go and view all the attack signatures for our policy on the attack signatures page. Over here it's going to show for the LoRack security policy, we're using 4,000 attack signatures. Pretty good. What are they all? They're all here. If you want, you can go through and read them all. You're probably not going to know what they all are. Just note that there are different signature types. There's header signatures, parameter signatures, URI signatures. But if you are looking for something specific, certain types of signatures, just for whatever reason, we can filter things down here. So for example, I could just look at all of my cross-site scripting signatures. I want to see them all. We have different security signature level types. We have low accuracy, medium accuracy, high accuracy. When it's low accuracy, we're going to have more potential false positives. High accuracy means less potential false positives. So I just want to see all the low accuracy SQL signature, cross-site scripting signatures, and now I'm viewing a smaller set. Because I could actually go through and remove some of these signatures if I wanted with those checkboxes. One of the things you'll notice as you're going through ASM, oh, and by the way, all our signatures are still in staging, just notice that. We'll talk about that after lunch. So as I'm doing stuff in ASM, sometimes I'll notice up here on the top right, left side of the nav bar, tells me there's new signature updates available. And that's because our team over in Tel Aviv are constantly adding and modifying all the signatures for ASM. And we kind of want to take advantage of the most current signatures. That's how we get the newest exploits. Most signature updates are done about every 6 weeks. However, our team in Tel Aviv actually do respond to critical 0-day types of attacks and put out new signatures in a much shorter time frame than that. Just depending upon the nature of the attack and the newsworthiness, I think, of the attack and so forth. So there's a few different ways that we'll get these signatures updated on our ASM. We can do it manually, or we decide when we want to do it. We can do it on a schedule, or we can just have it done in real time. As soon as those signatures are available, add them and apply them. Right now, the automatic aspect is disabled, so we're not doing real time. We're going to do it manually when I say I'm ready to do it. But we could select the other two options if we wanted to. So what I'm going to first do here is come to install updates. All of our signature updates are categorized, by the way. You've got your server technology signatures, our regular attack signatures, our bot signatures, and so forth. So when I click on install all updates, the first thing the ASM does is it goes and contacts the signature update server, which could be local. And this does not come up so quickly. It takes a little bit longer in the real world. They're going to say, hey, look, we have some new signatures. Attack signatures, browser challenge signatures, and server technology signatures. Excellent. I wonder what we just did. Well, for any one of these, I can select it, and I can see what we've applied. And if I want, so for example, I'm going to come here and take a look at my attack signatures. I want to see exactly what was done, because I'm just that kind of person. I got to know everything that was done. So I'm going to select the category. I'm going to select the most recent signature update. I'll get this page. Okay, that's got some details. That's interesting. I can scroll down. I can see all the entities that were added or modified or deleted. Any one of those is a signature. So it's interesting to note, we don't just add new signatures. Sometimes they remove signatures when maybe they've been deemed too many false positives. I'm not sure what they do over in Tel Aviv, but rest assured they know what they're doing over there. So these are all the new signatures that were added. But I really want to keep a record of this. I can't just do a screenshot of this. That's really hard to keep a record. We also have this README file. Oops, sorry. Go back there. The README file. And the README file is something that you can actually download and keep that on site in some manner. It shows every single thing that was done during that signature update and get us current, which is great. Now, a couple other ways we can do this. We can do it on a schedule. We can do it real time. If I go to real time, that basically means that ASM, as soon as it recognizes signature updates are available, it's automatically going to apply them. It's going to download them and apply them, adding, modifying, deleting signatures as requested. Or we can go to schedule. This is where I can pick exactly when to do what we just said. It's not in real time. I don't want it done until off hours. So I can specify that I want it to happen at a specific time, only after 2 a.m. And I only want this on a couple days of the week. I don't even want it any day of the week. I just want it to happen on weekends, Saturday or Sunday. So we can really pick when this updating of signatures is going to be done. If I don't want to do it manually. We can do it manually as well, I just showed you. And the last way you can do it, by the way, is if your ASM doesn't even have that direct connection to the internet that you need in order to do this, you can just go download the file from our download server and then upload it within the configuration utility as well. It's the fourth way you can do it. So, any questions on file type enforcement, file type list, the whitelist, signatures?
Just one question about the update of the signature. can we choose to have the updated signatures in a staging mode?
They always are actually in staging mode first.
Okay.
That's a default, and we'll talk about that more after lunch, but that is the default behavior. I don't even think you can change that. I think it always puts updated signatures in staging. Even if you take all your signatures out of staging, it'll always put the new ones in staging. We'll talk about that more after lunch, by the way. Anything else? So we're going to take about an hour and 45 minutes. Actually, let's do about an hour and 45 minutes. Let's take till about 1:40, and that'll give you time to do your lunch, do your exercise. You can do it in any order you want. You guys are on your own for lunch. In your exercise, you're going to start with a brand new policy. And in this policy, you're not going to add blocking mode or anything like that. You're just going to do the simple policy. Rapid deployment, that's it. And then you're going to add the ability to learn the new file types. You're going to generate some suggestions. You're going to look at those suggestions and add the appropriate file types to your whitelist, and then view the results. What happens now when I do forceful browsing attacks? Maybe they'll succeed. Maybe they'll succeed because maybe you need to change your enforcement mode. That's a possibility as well. And then you can play a little bit with the signature page and filtering and so forth.